Welcome to this video on functions. This is part 1 of 2. In this video, we will define a function, and then we will use algebraic, numeric, and graphical methods to determine if a relation is a function. In order to see these other 3 topics, please watch part 2 of this series. Let's begin. What is a function? In mathematics, a function is a specific type of relationship between 2 or more variables where there is a single, unique output for every input. Functions can be thought of as machines or black boxes. We put one value into the function and we get one value out of it. We call the input the independent variable and we call the output the dependent variable because the output or dependent variable depends on the input or independent variable and also on the function itself. Let's take the linear function y equals 2x plus 3. Which is the independent variable and which is the dependent variable? So first of all, we can fill in the function y equals 2x plus 3. The value that we are putting into our function is x, and the value that would be coming out of our function is y. So for example, let's say we put the number 2 into our function. Well, then we would have y is equal to 2 times 2 plus 3. So that's 4 plus 3, or 7. So if I put the number 2 into my machine, then the number 7 will come out. Functions versus relationships. Use algebraic, numeric, and graphical methods to determine if a relationship is a function. A relation or a relationship is a function if and only if, for every unique input, there is exactly one output. If a single input maps to multiple outputs, the relationship ceases to be a function. Let's take an example of an oven. Suppose you own a business and you make cookies. So you create your cookie dough and you use the same recipe every single time. You also always set the oven to the same exact temperature and use the same amount of time to bake the cookies. So all of your input variables are constant, but sometimes you take out cookies that are perfect and delicious, but other times the cookies come out being disgusting and burnt, even when, again, all of your inputs are exactly the same. So we would probably all agree that that oven is not functional, right? You can't depend on that oven to give you the same product. If you think about it, even if let's pretend it only ever gave you disgusting burnt cookies, right? That's still a constant output. We could probably change our input by perhaps reducing the temperature or the amount of time that we cook these cookies, and then we could get, perfect, delicious cookies every time. But when we can't control, we're not sure if we're going to get good cookies or bad cookies, then we would say our oven is not functional. Okay, and that's how functions work. If I have a given input and sometimes it gives me one thing and sometimes it gives me another thing, then it is not a function. There are several ways to determine whether a relationship is a function: algebraically, numerically, and graphically. Let's start with algebraically. In the following relations, assume that x is the independent variable and the y is the dependent variable. If possible, express the dependent variable y as a function of the x variable. In other words, get y all by itself on one side of the equation. If this is possible, indicate that the relation is a function. Otherwise, indicate that it is not a function. So if we look at our first equation, is y all by itself? Well, it's not, because we have y squared or y times y. Since y is not all by itself, we have to do something to get rid of the squared. So how do we undo a square? Well, what we do is we take the square root of both sides. Well, the square root of y squared is y, but remember, right, when we take the square root, we have 2 possibilities, the positive and the negative solution. So this is y is equal to plus or minus 2x. In other words, y could be 2x or y could be negative 2x. So since there are 2 possibilities, y maps to 2 different values of x, this is not a function. All right, let's keep going. We have x is equal to 8y squared plus 5. So in this problem, again, we want to isolate our y variable. So let's work on getting y all by itself on one side of the equation. The first thing I'm going to do is I'm going to subtract 5 from both sides. This gives me x minus 5 is equal to 8y squared. The next thing I'm going to do is I'm going to divide both sides by 8. So now we have y squared equals x minus 5 over 8. But again, when I go to take the square root of both sides, I still have this problem. I still have y is equal to plus or minus the square root of x minus 5 over 8. So since I have that ambiguity, it could be a plus or minus. I have two x values mapping to the same y value, and it is not a function. All right, let's look at number 3. So we have 3x minus y is equal to 9. So what we need to do is we need to see if we can isolate our y variable. I'm going to do this by first subtracting 3x from both sides. When I do that, I get negative y is equal to negative 3x plus 9. So the last thing I'm going to do is divide everything by negative 1. And so we get y is equal to 3x minus 9. This is a function. Not only that, it's a linear function. So we're fine. The next one, y equals 3. Well, y has already been isolated for us, so we know that it is a function. And then lastly, the equation, we have x squared minus 1 is equal to y. And again, y is all by itself on one side, so we know this is a function. Now let's consider numerically. When looking at tables of values, we need to ask whether a single input maps to multiple outputs. So again, let's just remind ourselves about the example of the oven, right? We put in good cookie dough, we set the time and the temperature, right? But sometimes they come out good and sometimes they come out burnt, right? So what we cannot have is that we can't have one x variable mapping to two different y variables. We cannot have that, okay? So let's see if we do in the first table. So we have 2, 3, 1, negative 1, 2, 0, and 3, 1. Pause this video and see if you can answer the question. If you said this is not a function, you are correct. So if we look at it, when we put 2 into our machine, sometimes we get out a 3 and sometimes we get out a 0. So since the x is, you can see the x repeats itself, or a better way to say it is that a single x value maps to multiple y values. This is not a function. Okay, so again, pause the video, see if you can figure out if the next one is a function. So do any of the x values repeat themselves? The answer is no. The y values do repeat themselves, but that's okay, isn't it? Because we can have all of these x values are different x values. Okay, last but not least, let's look at the third table. So do any x values map to the different y values? So the answer is yes. So we have 4 mapping to 0, and we have 4 mapping to 3. So again, this is not a function. Okay, and this is a function. So the last thing that we can do is the vertical line test. The vertical line test states that if any vertical line drawn through a graph of a relationship crosses the graph at more than one point, the relationship is not a function. Conversely, if every vertical line drawn through a graph of a relationship crosses the graph at exactly one point, the relationship is a function. So let's start with the first graph. So I can draw a line here, and it only crosses through one point. Here we're okay, but all of a sudden here, do you notice that this is passing through 2 different points? So this is not a function. How about the next one? Well, if I draw a vertical line here, it's very clear that it passes through two different points. I could have really drawn the line anywhere, almost anywhere on the graph, and it would have passed through 2 different points. So it is not a function. How about the next one? Well, again, we can see that it is a function because all of those vertical lines that I drew only pass through the graph at one point. So it is a function. Let's keep going. How about this graph right here? Well, you might think if you draw a vertical line here, it passes through the graph at 2 points. But let's look closer. This is a closed circle, which means the function is defined here. But this is an open function, an open circle, which means the function is not defined there. Therefore, this line does not, or the function does not violate the vertical line test at that point. You can draw vertical lines in other places, and you will see that they only cross the function at a single point. So again, since this is fine, because this open circle means the function is not defined here, this would be a function. How about the next guy? Well, it crosses at two places, so it is not a function. And last but not least, we can try the vertical line test again, and we see that any vertical line we draw on the graph only crosses at one point, so this would be a function. Let's revisit these table of values. So if you were getting confused by whether or not the x can repeat or that y can repeat, one easy way to help yourself understand this is to simply plot these ordered pairs. So let's take the first example. Let's plot 2, 3, and let's plot 1, negative 1. So that's going to be right here. And then let's plot 2, 0. So that's right here. And then let's plot 3, 1. So that's right here. So we can apply the vertical line test to these ordered pairs. Notice that these 2 points, right, the points 2, 3 and 2, 0, cause us to violate the vertical line test. So again, if the tables of values confuse you, you can simply graph the ordered pairs and then perform the vertical line test. So just as we said before when we were looking at this numerically, this is not a function. Okay, we can do the same thing with the next set of values. So we have negative 3, 1 is right here. We have 0, 1. We have 3, 1, and we have 6, 1. Okay, so all of these, right, are in different places on the graph, so it does pass the vertical line test. So we would say that yes, it is a function. So let's do the last one. Again, we have 4 ordered pairs, so let's go ahead and plot those points. We have the point 4, 0, we have the point 1, 1, we have the point negative 4, 2, and we have the point positive 4, 3. So again, when I go through and I try to draw vertical lines, this is fine, this is fine. These guys are not fine. So again, you have 4, 0 and 4, 3. Okay, so those 2 points, when we graph them, are in violation of the vertical line test. So we know that this is not a function. Okay, so again, this is just a separate way, a different way to answer the questions as to whether something is or is not a function if you're just given a set of ordered pairs. If you have trouble looking at the graph, or if you forget whether the x values or the y values are the ones that can't repeat, simply plot these on a graph, and then that will help you remember or figure out, using the vertical line test, whether you're being given a relation or an actual function. All right, let's do some more practice. Is this a function, yes or no? Pause the video, do a vertical line test, and then unpause it to see if you are right. Okay, this is a function. It passes the vertical line test. How about this one? Okay, this is a function, absolutely. Also, if you read your directions, it says to put a star if it's a linear function. Okay, this is a linear function. How do we know? Because it's a straight line. How about this one? Does this pass the vertical line test? Yes, so it is a function. It's also a straight line, so it is a linear function. How about this guy? Well, it's pretty obvious that he fails the vertical line test here, right? So this is not a function. Okay, how about this? So it looks like a straight line, right? So you might think, oh yeah, it's a linear function, but is it really a function? Does it pass the vertical line test? Well, no, right? Because if I drew a vertical line over top of it, wouldn't that vertical line cross it at infinitely many points, right? So it's not a function. How about the next one? Is this a function? Yes, it is. It passes the vertical line test. How about this one? Yes, this is a function. In fact, it is a linear function because it is a straight line. And last but not least, how about this guy? So if you said it is not a function, that is correct, right? If I draw a vertical line, there are a lot of different places I can draw a vertical line where it crosses the relation more than once. So it is not a function.